Today we're going to look at the proof of the proportionality theorem, and what this theorem states is that if you have a triangle, in this case triangle ABC, and you have a line drawn parallel to a side of the triangle, so in this case DE is parallel to side BC, then what happens is that the line DE divides the other two sides of the triangle in proportion. What that means is that AD over DB is equal to AE over EC. There are a couple of things we need to understand before we get to the actual proof of this theorem, and these may or may not have been things that you've picked up over the years. But the first thing we want to look at is if you have two triangles that lie between the same parallels, then they're going to have the same height. Now that should make sense to you because parallels obviously are equidistant apart. So no matter where I draw that vertical line, if I drop it from the vertex here, or I drop it from the vertex here, these triangles will all have the same height. What we can therefore say is that the areas of these two triangles will be in the same ratio as their bases. So if, for example, the first base is 3 centimeters and the second base is 5 centimeters, then the areas of these two triangles will be in the ratio 3:5. That makes sense in terms of, let's just call that H, and we know those H's are equal, is that the first area would be a half times 3 times H, and in ratio to the second area, a half times 5 times H. Obviously the halves and the H's cancel, and that is just 3/5. So that should make sense to us. A similar scenario is where you have two triangles that share a common vertex. Now, that's the common vertex that I'm talking about here. These two triangles have got bases BD and DC, and it also should make sense that the reason they have the same height is that from A, perpendicular to the base. Now remember, a height does not need to be inside a triangle. So don't get fixated on the fact that you've got this height and it doesn't appear to be inside this triangle. It doesn't matter. It is still the height of triangle ADC. The base of triangle ABD is BD. The base of triangle ADC is DC. But they both have this common height, which we're going to call H. Again, their areas will be in the same ratio as their bases. And we can see that. I'll do the ratio as a fraction this time. So triangle ABD has got an area a half times BD times H, whereas triangle ADC has got an area a half times DC times H. Obviously your halves cancel, your H's cancel, and hence their areas are in the same ratios as their base. Now both of these two statements are going to be used in the actual proof. So in this theorem we're going to be given a particular sketch. In this case we are given triangle ABC and we're given that DE is parallel to BC, and we want to prove that AD over DB is equal to AE over EC. My proof is based on those last two statements that we've seen on the previous 2 pages. Now firstly, we're going to look at the area of triangle ADE, so that's this triangle here, over triangle DBE. Now you might say, well, where's triangle DBE? Well, we need to make a construction. Obviously learn your proof properly from your textbook, but we would need to state that we're doing the construction, but there's my construction. So what we have now is we have two triangles that share a common vertex, and the two triangles we're talking about are ADE and DBE. So the common vertex is E. And obviously that height that we would have seen for those two triangles would have come in here. Now you don't have to draw that, but it's just in case you need to see it. And then it should make sense to you that we're going to compare the area of that triangle and the area of that triangle. And what we've seen on the previous page is that those areas will be in the same ratio as their bases, and their bases are AD and DB. So we have the area of triangle ADE over triangle DBE is equal to AD over DB. And the reason that I would use there is triangles have common vertex. In a similar way, we have triangle ADE over triangle DEC. So again, I would have to join D to C. And their areas will be in the same ratio as their bases, which are AE and EC. And that would obviously be because D is the common vertex, so their shared height, perpendicular height, is over there. And again, my reason would be triangles have common vertex. Now, what we need to understand is that we have the two parallels over here, which have the triangles DBE and DCE lying between them, which means those two triangles have got the same height. However, those two triangles also have equal bases. So they've got the base DE and the same height because they're between the parallels, which means that the area of triangle DBE must equal the area of triangle DEC. So that's what we're saying over here. But DBE equals DEC. My reason there would be equal base and lying between same parallels. But that means that these two fractions here have got to be equal. They've got the same part on the top. And we've now said that DBE and DEC are equal. So the bottoms are also equal. And obviously, if the tops of the fractions are equal and the bottom of the fractions are equal, then the whole things are equal. But that fraction is AD over DB, and these two areas are AE over EC. Hence, we have proven what we were required to prove.